Everyone, today we shall discuss few more important questions of DMS, and these are 5 marks questions. Okay, so the first question is discuss operations on set with Venn diagram. This we have already discussed in the previous classes. So there are totally 5 operations. First one is union of sets. Union means what? We need to consider all the elements of two sets. For example, if A is 1, 2, 3, 4 and B is 2, 3, 4, 5, 6, then A union B will be what? We have to consider all the elements of A and B but without repetition. So A union B will be 1, 2, 3, 4 and 5, 6. So this will be the union. So in generally, this is an example. General format will be like this. A union B is equal to variable x such that x belongs to A or x belongs to B. Means the element of union set may belong to either A or B. Okay. So in the Venn diagram, it will be like this. Set A, set B, okay, and we need to shade the whole portion of A and B. So this will be the Venn diagram for A union B. So in example, when we take the example, we need to write the elements here. See, for example, the common elements are only 3 and 4. Okay, so 3, 4 we can write it here, and remaining 1, 2, and here we have 5, 6. So this will be the union of sets. Okay. Next, intersection of sets. So intersection means that will be like this, A intersection B. So here we need to take only the common objects. So that is equal to x such that x belongs to A and x belongs to B. Means it should be common, the element should be common in both the sets. So which are the elements common here? Only 3 and 4. So the Venn diagram will be like this. Okay, so here we need to shade only this portion, intersection portion. So this is A intersection B, here is A and here is B. So the common elements are 3 and 4. Okay. Next, complement of a set. So complement of a set means what? See, here we have to consider the universal set. Okay. See, if the universal set is having elements like this, 1, 2, 3, 4, 5, and A will be 2, 4, 5. Okay. Then the complement will be written as A complement is equal to universal set minus A. So that means what? A complement means the elements present in universal set but not in A. Okay. So which are those elements? 2, 4, 5 we have to leave. Remaining 1, 3. Okay, only 1, 3. So here this is written as A complement will be an element in a variable x such that x belongs to universal set and x does not belong to A. Okay, so this is about complement of a set. Now how to represent this using Venn diagram? See, this is A, okay, and then this becomes A bar. Means elements of A bar only. Okay, so in that case we need to shade the whole rectangular box except this set here. So this is A complement. Okay. Next, relative complement. So relative complement means it is represented like this. B minus A. Okay. So B minus A means what? Here variable x such that x belongs to B and X does not belong to A. So here, as usual, let us consider the same examples. Okay, so A is 1, 2, 3, 4 and B is 2, 3, 4, 5, 6. So here in this case, B minus A will be, okay, so the elements which are present only in B but not in A. So which are those elements? 2 present in A, 3 present, 4 present, 5, 6 not present. So only 5, 6. So B minus A, that is relative complement, means if it is B minus A, then the elements present only in B but not in A, that we have to consider. Similarly, A minus B means what? The elements, okay, X, it is an element X such that X belongs to A and X does not belong to B. Okay, so A minus B will be what? The elements present only in A but not in B. 1 present only in A. 2, 3 present here. 4 present here. Okay, so the answer is only 1. So how to represent this in Venn diagram? This is A, okay, and this is B. So if at all it is B minus A, then we need to consider the elements of only B. So this is B minus A. Then what is A minus B? So this is A and this is B. So this is A minus B. Okay. Now the next one is symmetric difference. So now the last one is symmetric difference. Symmetric difference is represented as like this. Symmetric difference will be, okay, X such that X belongs to A union B and X does not belong to A intersection B. Okay. So in general, A symmetric difference B will be A union B minus A intersection B. Okay. So now let us take the same example here. So what is A union B first? A union B will be next A intersection B will be common, which are common 3, 4. Okay. Now A symmetric difference B will be equal to A union B, that is minus A intersection B. Okay. So now write down except 3, 4, here remains with 1, 2, 5, 6. So this is the symmetric difference of A and B. Okay. Now how to represent this using the Venn diagram? That will be like this. So A, B, okay. So here in the intersection we have 3, 4, okay. And now what remains in A here? 3, 4, except 3, 4 remains with 1, 2. And here except 3, 4, 2, 5, 6. Okay. Now we are having, okay, 1, 2, 5, 6. 1, 2, 5, 6. Okay, 1, 2, 5, 6. Okay, so that means only this portion except intersection portion. So only this portion is not shaded here. So this is A symmetric difference B. Question is state and prove distributive property with truth table nonsense. So here we have the distributive properties. 2 we have actually. Okay. So A union B intersection C will be A union B, okay, intersection A union C. Next, A intersection B union C will be A intersection B union A intersection C. Okay. So let me prove this first. As usual, A, B, C, 3 inputs we have. Okay, so first let us prove the first one. We need P intersection C. So P intersection C, then we need A union B intersection C. Okay. Next will be, this is about LHS. RHS would be A union B. Next A union C. Next we have A union B intersection A union C. Okay. So we have to prove that LHS is equal to RHS. Okay. Now let me write down the inputs. Okay, see here. B intersection C. Either of the inputs is 1, then output will be 1. Okay, next. A union this. A union this. All first 4 outputs will be 0 here. Okay. Next 0. Next all 3 1s. Okay. Next. So this is LHS. Now coming to RHS, first A union B. So A union B 0. Next 0. 0 into 1 0. Again 0 into 1 will be 0. 1 into 0, 1 into 0. Again 0 0. Next 2 ones. Okay. Next A union C. See, as first 4 zeros. Okay. After that, see here, fifth one 0 0 1 0 1. So now intersection of these two. One it is. Okay. See here 1 0 will be 1. So now compare these two, LHS and RHS. Yes, both are right. So similarly, you have to verify with the second distributive law also. I hope you will verify this.